Hi everybody, this is the 13th week and we will continue with a question with 12th week. This one is our question. I hope you will remember these things. Find an equation for the tangent to the curve y is equal to x plus 2 over x at the point 1 axis and 3 ordinates. And so, you know that first of all, we have to find the derivative with respect to x, derivative of y with respect to x. So, for the solution, we have to write this one. That is this one also. So, derivative of x is 1, and derivative of 1 over x is, you see, 1 over x squared. Minus 1 over x squared, and we have 2 here also. So finally, to find the tangent at the point 1, 3, so we have to put 1, that is this one, 1 squared, and we find minus 1. So finally, this minus 1, you see slope. So we have the point and the slope. So we can easily write the line. So here, ordinate and slope here, and x minus 1 axis here. So that is y minus 3 is equal to minus x plus 1. That is plus 4. This is a tangent line for the point 1, 3. Now we have another subject. It is second and higher order derivatives. Let's write it. Second and higher order derivatives. You can do these things by examples. Let's say y is equal to f of x is equal to x to the power 6. So y prime, that is y with respect to x, first derivative, is 6x to the power 5, you see. Let's find second derivative. Then this is derivative of y prime with respect to x. So it is 6 multiplied by 5 and x to the power 4. This is 30 x to the power 4. So this goes like that. Third derivative is y second prime and with respect to x. And this is 6, 5, 4, and x to the power 3. This is 120 x to the power 3. Here, y prime, as I said, can be written and can be said also y prime. And this one, y double prime. Also, we can set like that, delta square y over delta x squared is d squared y dx squared. Also, we can use this one. And also, for y triple like that, y triple prime. And finally, we have like that d to the n. We can use like that. And we have also like these things. Let's use this space here for that one. And delete also this one. Yeah. This one is ny and dxn is delta to the n of y by dx to the n. We can use these things for saying the notations. And finally, I have one more thing. Y to the n. This also equals d to the ny here like that, and also we can write that. And derivative of y with respect to x. We can also here write that with respect to in abbreviators. And next one, we have some questions for this one. Y is equal to x to the power 3, x cubed I mean, 3x squared and 2. The question is find the second and higher derivatives. Also, we have to find the first derivative also. First derivative is y prime is equal to 3x squared minus 6x, you know. Second derivative, y double prime, 6x minus 6. And third derivative, third derivative, you see it is only 6. And if you want to find the fourth derivative, you want to find fourth one, you see that it equals 0. This is constant, so it is 0. Okay, another question. The area of a circle, is related to its diameter by the equation. We have this equation, p over 4 d squared. D is the diameter, you know. Question is, how fast does the area change with respect to the diameter when diameter is 10 meter. So we understand from here that the question is dealing with finding the derivative of the equation, area of the circle of the equation, and of course with respect to diameter. And after finding the diameter derivative, we have to put this 10, so we'll find it as a solution. Yeah. First of all, we have to find derivative of a with respect to d. So it is, you know, we have constant pi over 4 and derivative is 2d. and we can cancel these two things, and PD over 2 is the derivative. And when d is equal to 10, we can find that it is pi over 2 multiplied by 10, and it is 5p. So it is this meter square, yeah, meter square over m. The area changes, the area changes 5p meter square over meter. This is the answer of this question. Now, next one. Now we have derivative in physics. We have some examples about physics. Let's write it. Derivative in physics. We have some definitions. So these are velocity, speed, acceleration, and jerk. Now let's give the definitions for these things. Velocity is derivative of s with respect to time. This is our function. So this function's derivative with respect to t. We will find the velocity. So this is instantaneous velocity. So let's find speed. Speed is the absolute value of the velocity. If you know the time, so we put the time of the derivative of the s with respect to t, and when we put in the absolute value, we will find the speed. And this one is speed is equal to vt in absolute value, that is delta s over delta t in absolute value. And acceleration is the derivative of velocity. So this is, let's show it by AT. AT is delta V over delta T. That is, we know that V is equal to delta S over delta T. So we can write acceleration by delta square S over delta T square. And we also know that acceleration is the definition of this one, I mean, a vehicle's capacity to gain speed with a short time. This is acceleration. And finally, we have jerk. And we can write it by like that. Jerk is the derivative of acceleration again, is the derivative of acceleration with respect to time, with respect to t. And jerk's definition is jerk a quick, sharp, sudden movement. Sudden movement. So, if you want to show the definition of G by G, and it is delta A over delta T. So we know a T is here, so it is delta cube S over delta T cube. So we have this formula, and we have here another formula, and we have finally third one is here, and fourth formula for speed. We have to know these formulas, okay, for the exam. And for these things, if you want to write a question, this one is our question. At time t, at time, let's write true, at time t, the position of the body, position of a body moving along the s-axis is s is equal to t cube minus 6t squared plus 9t meter. So question is like that. A, what is the velocity of this body? What is the velocity of this body? First, we have to find this one. Second, what is the speed? What is the speed? You may write like that. What is the velocity function? Maybe velocity function. It's maybe better to write for the question. Velocity function. Also change my notes. Velocity functions. Okay. What's the speed at t is equal to 2? And third question is for C part. What is the acceleration? What is the acceleration at t is equal to 3? And finally, for D, what is the jerk? What is the jerk at t is equal to 1? First of all, we have to find velocity. So we are going to find the derivative of s with respect to t. That is Vt is equal to delta s over delta t. That is 3t squared minus 12t plus 9. And this is meter over t. This one is okay. Now, what's the speed at t is equal to 2? So you know that speed is absolute value v, but we have to find it at t is equal to 2. So it is in absolute value 2 squared minus 12, 2 multiplied by 2 plus 9. So it is you see it is 412 minus 24 plus 9. So it is minus 3 in absolute value, and this is 3. 3 is speed of our body at time t, 2, sorry. What's the acceleration at t is equal to 3? So for the acceleration, we have to find delta v over delta t, that is delta s square, delta square s over delta t square. That is the derivative of this one. So 6t minus 12, but it says it is at t is equal to 3. So when we put 3, It is 6, I think. Okay. What's the jerk at t is equal to 1? Jerk is jt is equal to derivative of a with respect to t. So finally, we find from here, derivative of here is 6. So 6 is whatever t is. You see, question is for t is equal to 1, but it's not important whatever it is, t is 1 or 2 or 3, it's whatever. So gt is equal to 6. Now, this is okay for physics, and now we are going to talk about some economics. Okay. Derivative in economics. In economics, we have to know that, of course, some things, some definition of things, so we can write about these things. Total cost is costs for producing all products. In economics, we have some assumptions or maybe like these things. So we think that we produce some products and we sell all of these products. So total revenue is revenue selling by all products. So first producing of the products and selling the products, the produced products, so we can find the total revenue. And for the total revenue, we can find that total revenue is price multiplied by quantity. Quantity is not important for you, but you can know this one. And for the total cost, we have fixed cost. You may hire a place or you may buy some things before producing anything. So after producing part, starting, so you have also variable cost. This is total cost, and total revenue is price multiplied by quantity. So finally, we have also P. This is profit. Profit is equal to total revenue minus total cost. And now the derivative part. Also, our aim is as a producer, getting positive profit. Now, derivative part, MC is marginal cost. That is the cost of producing one more product. This is marginal cost, and MR is marginal revenue. This one is increase in revenue by selling one additional unit. If we sell one additional unit, we can find our marginal revenue. And if you want to find the marginal cost, we can easily find the cost of producing one more unit or one more product, you may say. And we have 5 more minutes, and now Okay, let's stop. Here we can write our question, and maybe we can solve it in the online lecture. Our question is like that. Suppose that it costs Cx is equal to x cubed minus 6x squared plus 15x dollars to produce x radiators when 8 to 30 radiators are produced, and that our total revenue, I mean, x cubed minus 3x squared plus 12x gives the dollar revenue from selling x radiators. Your shop, it says you have a shop, and your shop currently produces 10 radiators a day. Now the question is coming about how much extra, will it cost to produce one more radiator a day? And this one is the first question. And what is your estimated increase? It says estimated. Don't forget this one. We will talk about this one in the online lecture. Increase in revenue for selling 11 radiators a day. Now this is in fact an easy one, but this is about our subject. And first question is here about how much extra will it cost to produce one more radiator a day. This one is about total cost. And another question is, what is your estimated increase in revenue for selling 11 radiators a day? This is, of course, this is not the question for 11 radiators, but it says, what is your estimate increase? This one is a bit different. So we can find it in the online lecture, I think. See you on online lecture. That's all for today. Thank you.